Hey guys, how's it going? My name is Ted Tryon, and today I'll be showing you a new addition to the Mitchell Tech SCADA Lab projects. I'll show you guys everything I did to get it to where it's at, but first I just want to say a special thank you to everyone that helped me with this project. I had a lot of people at my job helping me with everything from building the panel to assembling and programming the system. I had never worked on a Click PLC or a Schneider Electric HMI before, so it was a very big learning curve, and I couldn't have done it without their help. So before I go on and show you guys my project, I just kind of want to show you how it was started. So this drawing here is a rough sketch that Josh had given me. He came to me and said that he wanted a new project built for the lab. On the left there is a tank and then a temperature transmitter. We got a few pressure transmitters in there, the pump, a flow meter, a valve, more temperature sensors, and a heater. He was trying to utilize as much stuff that we got given from Muth Electric. We had a bunch of rod level sensors, a bunch of pressure transmitters, which ended up not being able to be used, sadly, but we did use some of the things Josh had given me, like the pump, the flow meter, and the valve, the pneumatic valve. But everything else was donated by Dakota Pump to be used for the project. And here is how it ended up. This is the drawing of how we built it at Dakota Pump. And that's kind of just like the progression. We found out that even with Josh's drawing that it wasn't going to work as well as he thought it was going to. So we ended up just having to build it at Dakota Pump. And yeah, this is how it ended up, and I'll show you guys everything now. To start, I'm going to show you guys how this system works. As you can see, we have 3 tanks here, but we're only using 2 of them. What we're trying to do here is simulate a 1-pump booster station that simulates a system that keeps a constant pressure, but also a constant flow. We're treating this area here as if it were a town or house that is using water, and this area here would be transmitted on, but we have it set up to keep a constant loop so we don't have to worry about low levels or anything like that. So water is going to come out of this tank here, and we can read the pressure coming out of that tank. It will then go to the pump, and the pump will increase pressure and continue on to pressure 2. And if this valve is closed, this manual valve here, we can continue flow this way, and we can dictate how much flow we get from this flow meter by using this valve. We're going to dictate pressure by using a PID with pressure 2 as our process variable. So if we're trying to maintain 50 psi and the system is at 30, the pump frequency is going to increase until we get to that 50 psi. Then it's going to keep a steady frequency. We are also going to be using a PID for the flow meter, and we are going to be using the flow meter as the process variable, and we're going to keep the valve as the output. So if we want to keep a 3 gallon a minute level, we're going to either increase or decrease the value or how open the valve is. So if the valve is 100% open and we are trying to get 6 gallons a minute and we're actually at 12 gallons a minute, we are going to decrease the value of this valve until it reaches the flow meter set point that we want. So this here is the pre-built, or as much pre-built as I could for my schematic drawings. I couldn't actually find my pre-build drawings, but this is before my analog cards went haywire, so I did have to do a bunch of editing to get my project to work, but this page didn't change at all. This is pretty straightforward wiring and whatnot. I have my transformer with 2 phases of my 3-phase 240 coming in, and then coming out is my 120, and my neutral going to my surge protector, which is feeding my DC power supply, which is feeding the rest of my drawings. So if we move over here, we can see that I have my e-stop circuitry and my HMI. If we go into the second page, you can see that we have our old PLC here with our digital outputs, digital inputs, and analog outputs. Here we have another module that's not being used. This is my 4 analog in, 2 analog out. That fried. We are going to the third page. This was kept. This is my 16 digital input module that I am using for all of my panel door inputs. And then these 2 modules, I assume that I had fried when I had first applied power. It was my mistake. Not totally sure what had happened, but those 2 are now dead. And this is my VFD. The only thing that changed in this was the 54 analog in. We had to use 53 because of some issues with the drive, but we switched it over to 53, and I will show you that real quick. Here is my as-built. So everything in these next few pages will be as everything is in the panel right now. So like I said, everything in here is the same. So we'll just move on to the second page. This here is the new PLC. As you can see, we have more analog inputs, but other than that, everything else is basically the same. I had to move my pressure transmitters to this analog input section of the PLC because I had no more analog input modules to use. The 16 digital input module was moved here because everything else freed up a whole lot of space. So these are the only 2 modules I'm actually using in the panel. And if we move on here, we can see my VFD wiring. And the only thing that has changed here is, like I said, the 53 port for the analog input for the VFD so that we could send the frequency to the VFD to get to the pump. So this is how our network is set up. We have our cellular modem here with our signal from Verizon. It's sitting on this IP address right here, just our 166 IP. And from that signal from Verizon, we have our Ethernet port 1 going straight to our PLC right here. It's at this IP address that was given from a range from Josh. And our second one here is going to our HMI at this IP address here, just again that range that we got. These cellular modem I had never worked with before, so it was a big learning curve for me, but I ended up needing to get help. But they're pretty useful because you can remote in just about anywhere without the use of a radio, anything like that. But yeah, they're super useful, super nice when they work, but other than that, it was a big learning curve for me. So here is what the panel had looked like before we had to remove the bad analog input-output cards and also change out the PLC. And here is what the panel looked like after. As you can tell, we have a lot more room up top with those 3 modules getting taken out. In the bottom right, you can see the transformer, the big black brick you see there. It's being fed by those 3 terminals to the left of it from our 240 coming in, going to the transformer, and then carrying on to our 120 terminal blocks, going to the 24-volt power supply. You can see our surge protector, our cellular modem in the top right, and obviously the PLC in the top left. Here I'll be showing you my HMI. This is a Schneider Electric HMI using VA host software. We can see here our pump information and our valve information. We can see that the pump is called to run. It's running at 77% of our maximum frequency, and it has ran for 166.2 hours. For our valve information, we see that the valve position is at 65% of its maximum openness. If we move on to the menu, we can see our different pages that I'll go through individually here. For our automatic set points here, this is for auto mode. We are maintaining 50 psi for our PID and also 3 gallons a minute for our flow PID. If we went back to menu and continued on, we could see our hand controls. This is for hand mode. You can select the frequency you want and also the position that you want the valve open. Moving on, we can see our runtime totals. Again, our pump has ran for 166.2 hours, and we have had 21 number of starts. We can go to our alarms menu, and we can see our pressure alarm settings and our flow alarm settings. Now we can see in the pressure alarm settings that we have high pressure alarm and low pressure alarms. So we have the suction pressure at 65 for the high and suction pressure at 20 psi for the low. Discharge pressure is the same, and at the transmission pressure, 30 psi is the high, 1 psi is the low, because usually that manual valve isn't closed all the way or open all the way, just because we can't keep a very high pressure that we want, and also that affects the flow rate as well. Now if we move on to the other alarm settings, we can see the flow meter high set point and flow meter low set point, and also the flow meter value. We're at 8 gallons per minute for the high and 2 gallons per minute for the low, just because we want to keep that in between those 2 points. But if you ever wanted to keep higher than that, you'd go in here. Just make sure that you don't trip any other alarms. If you go back to the menu and you continue on, you can see the PID settings here we have. So for our pressure PID, we have the P, the I, and the D that you can all change in through here. This was not the actual final measurement or the final numbers I used for the PID. I went through and I took photos as it was running, as I was trying to figure it out. This was working at that time, but I did have to change a few things to get it to that perfect curve that we wanted. We move on here, we can see the set date / time, and this actually helps. As you can see in the lower right corner, you actually do have the time and the year in there. This was before I had changed it back to its time in there. Obviously it is not January 1st, 2000. Happy New Year to everybody. But yeah, this has been my HMI so far, and now I will show you the pages for changing the automatic set points in auto mode and changing the variables in hand mode. So for this demonstration, I will be showing my PID settings. So for the automatic set points here, as we are in pump auto and valve auto mode, we can see here that the pressure is set to 45 psi, and we are maintaining that pretty well. And the flow is set to 5 gallons a minute, and we are maintaining that perfectly. So if I wanted to set this to 30 psi, the frequency on the pump will drop until that reaches 30 psi, and the valve will catch up slowly to get back to that 5 gallons per minute. Now, if I wanted to change this to 3 gallons a minute, I'll enter 3 here, and that valve will close, and then it'll slowly bring it back up. Small amount of oscillation, not too much to worry about, but we're maintaining our 30 psi with 3 gallons a minute. Now there is a quirk with this, that if I wanted to set the psi low enough that the valve would not be able to keep up, so say 6 gallons per minute here, at here we can keep it at 6 gallons a minute, but if I decrease the pressure it's not going to be able to keep up. We can maintain pressure, but we won't be able to maintain flow. Now, if we put that back up, obviously it will be able to maintain that gallons per minute. Now, with both of our valve and pump in auto mode, we can see that we can change the percentage of the frequency of pump. So from 60% we can go to 70%, and we can watch how that changes the pressure. We can send it to 25% pump power, and that changes the pressure down there. With the valve position at 100%, I'll increase this so it's easier to see. We go from 7.8 gallons per minute. We drop that to 50% closed. We get 1.6 gallons per minute. Again, 25%. And we'll switch it back to 100. So yeah, this has been my final project for SCADA. Make sure you guys smash that like button, hit that subscribe, and make sure to ding that wacky bell to get them notifications for the next time SCADA Lab uploads. Peace.